Here we're going to do the analysis of a non-inverting amplifier. So here's the non-inverting amplifier circuit. You can see it's quite different than the inverting amplifier or the summing amplifier because look, Vin connects directly to the non-inverting input of the op-amp, where in the inverting amplifier case and the summing amplifier case, the non-inverting input was grounded. Okay, so this is a vastly different way of connecting up the op-amp. Now there is a feedback resistor between Vout and the inverting input, and also there's a resistor, as you can see here, that connects from the inverting input to ground. So we're going to come up with the closed loop gain ratio of Vout to Vin for this circuit, and we're going to do it the same way as what we did in the previous circuits, where we write a node voltage expression here at the node where the feedback connects to the inverting input. So remember again that we always have a virtual short with a ideal op-amp. So this is probably the third or fourth time I've written this. That ideally at the input of an op-amp, the current and the voltage are both zero. That's what a virtual short means. So right here at the input of the op-amp, both these values, the current and voltage, are zero. So I start off with the KCL equation at node A, and I've got IB flowing in and IA flowing out, as well as little I flowing out, but again that's zero. So I'm just left with that IB equals IA. Okay, and now I write these currents in terms of voltage using Ohm's law. So Vout, or excuse me, IB is going to be Vout minus VA over RB, and then IA is just VA divided by RA, right? Since the bottom side of RA is connected to ground, which is zero, so VA minus 0 over RA. All right, now look, remember in the inverting amplifier case and also the summing amplifier case, VA was equal to 0 because this voltage across the input of the op-amp, or across the inputs of the op-amp, is 0, and the non-inverting input was grounded in those two circuits. Well here, like I said before, Vin, our input voltage, is connected right to the non-inverting input. Okay, but this voltage across the inputs is still 0. That's part of the virtual short, which again means the voltage on both inputs is the same. So since we have Vin at the non-inverting input and there's 0 volts across the inputs, the inverting input, which is node A, is also equal to Vin. So you see VA here, we'll write it over here, VA is equal to Vin. So if you go ahead and substitute in for VA, Vin, and then rearrange the terms, you can show that the closed loop gain for this non-inverting amplifier circuit is just equal to 1 plus the ratio RA plus RB, which can also be written over common denominator A here. Okay, so you can see that the closed loop gain here for this non-inverting amplifier, there's no negative sign, so no inversion is taking place, so that's why it's called non-inverting. So your output and your input voltages are going to be in phase. Okay, if your input voltage is positive, the output's going to be positive. If your input's negative, the output's going to be negative. Also notice that you can't have your closed loop gain less than 1. See, that's another fundamental difference between the inverting amplifier case and the non-inverting amplifier case. See, one fundamental difference, and it's right in the name, is that one inverts, the other doesn't. But another fundamental difference is that with the inverting amplifier, okay, if you recall, its closed loop gain minus, and it was just RF over the input resistance, okay, which was R1. Well, you see, with an inverting amplifier, you can do what's called attenuation as well as amplification. Attenuation is when you make a signal smaller, okay? And clearly, if I make R1 larger than RF, well then Vout is going to be less than Vin, and that's what's meant by attenuation. It's just the opposite of amplification. But you see, you can't attenuate a signal with a non-inverting amplifier because this closed loop gain could never be less than 1, right? Because if you made the feedback resistor 0, let's say, where this term went away, well, you'd still be left with 1, which means Vout equals Vin. So that's just an important distinction between the non-inverting case and the inverting case, in addition to the fact that one has a 180-degree phase shift between the output and the input, and the other one doesn't. Okay, just remember that. You cannot attenuate with a non-inverting amplifier. If you wanted to attenuate, make the output signal smaller than the input signal, you would have to use an inverting amplifier.